Hello students, let us solve this Irodov problem number 1.16. Two particles 1 and 2, particle 1, particle 2, move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. There are two lines which are mutually perpendicular. This is the line and their intersection point is O. There are two particles, particle 1 and particle 2. Particle 1 is moving along this line with constant velocity v1 and particle 2 is moving along this line with constant velocity v2. Particle 1 is moving towards intersection point O and particle 2 is moving towards intersection point O. So, this is the situation. At the moment t equal to 0, initial, the particles were located at the distance L1 and L2 from the point O. Initially, this particle 1 is at a distance of L1 from O and the particle 2 is at a distance L2 from point O. Okay. How soon will the distance between the particles become the smallest? So, we have to calculate the smallest distance and the time when distance between the two particles become smallest. So what is it equal to? So we have to calculate two things. First, the smallest distance between these two particles, and second, at what time this distance becomes smallest. So how we can proceed? First, to solve this problem, both particle 1 and particle 2 are moving. So what we do is first make this particle at rest. Okay. So initially this distance is L1 and this distance is L2. So I connect these two particles by a straight line. These two particles by a straight line like this. Okay. So this is a straight line. What is the distance? This angle is 90 degree. This is L1, this is L2. So this distance is under root L1 square plus L2 square. Okay, let me call it this distance as S. Can I find this angle? Yes, we can find this angle. So I call it alpha. This angle is alpha. So tan alpha equal to L1 by L2. So I got a number tan alpha equal to L1 by L2. Okay. Now to solve this problem, I have to make this particle at rest. For that, I impart a velocity v1 in minus x direction. So I must impart a velocity v1 in minus x direction to particle 2. Okay, so this is the situation. Now particle 1 is at rest, so I rub this part. Now there is no velocity to particle 1 is at rest and particle 2 is only moving. In which direction particle 2 will move? The direction of resultant velocity of v1 and v2. So what is the resultant velocity? To calculate resultant velocity, I draw a rectangle like this. So the resultant velocity is in this direction. Okay, let me call this resultant velocity as v. What is the value of v? V should be equal to under root v1 square plus v2 square. Okay. Now, this velocity and this line have different angle. So, if I calculate this angle, let me call this angle as beta. So, tan beta equal to this length divided by this length. So, tan beta equal to v1 divided by v2. Okay. Now, this particle will move along this line. Okay. So the minimum distance between this particle and this particle occur when a line drawn from particle 1 will make angle 90 degree to this. So this is the situation. So at the time when this particle reaches this point, so the distance between these two particles is minimum. Okay, now I understand the situation. Now there is no use of this line, so I rub this part. Now I have to solve only this triangle, but this full angle is alpha and this angle is beta, so this angle is alpha minus beta. So I rub this part also and make this triangle clear to visible. So now this is the situation. The second particle from this position is moving towards this line with an angle of, this angle is alpha minus beta. Okay, now this triangle is good. This is a right angle triangle and this is the hypotenuse. So this length is S cos alpha minus beta and this length is S sin alpha minus beta. Okay, this is the minimum distance. So first answer is this, and for time this is the distance, this is the speed. So distance divided by speed is the time. So I can calculate the distance and time only when I find sine alpha minus beta and cos alpha minus beta. For that tan alpha and tan beta I have already calculated. So I know the formula that sine alpha minus beta is equal to sine alpha into cos beta minus sine beta into cos alpha. Now tan theta equal to perpendicular by base and sin theta equal to perpendicular by hypotenuse. So this number is perpendicular L1 divided by under root L1 square plus L2 square. What is cos beta? Tan beta is perpendicular by base. So this value is V2 divided by under root V1 square plus V2 square. Okay, I calculated this part. Now minus sine beta. Sine beta means this. So it is equal to V1 divided by under root V1 square plus V2 square. Okay. Now for cos alpha, this is equal to L2 divided by under root L1 square plus L2 square. So I got that sine alpha minus beta should be equal to, denominator is same in both the parts, so it is equal to L1 V2 minus L2 V1 divided by under root L1 square plus L2 square into under root V1 square plus V2 square. So this is the value of sine alpha minus beta. Similarly, I can calculate the value of cos alpha minus beta. So cos alpha minus beta should be equal to cos alpha into cos beta plus sine alpha into sine beta. So what is the value of cos alpha? This is alpha. So it is equal to L2 divided by under root L1 square plus L2 square. Okay, what is the value of cos beta? For beta, this is V2 divided by under root V1 square plus V2 square. Okay, now this is plus sine alpha, alpha L1 divided by under root L1 square plus L2 square into sine beta, this is beta, V1 divided by under root V1 square plus V2 square. So cos alpha minus beta is equal to, denominator is same, so L2 V2 plus L1 V1 divided by under root L1 square plus L2 square into under root V1 square plus V2 square. Okay, so I got the value of cos alpha minus beta and sin alpha minus beta. Now let me write it clearly. Sin alpha minus beta is equal to L1 V2 minus L2 V1 divided by under root L1 square plus L2 square into under root V1 square plus V2 square. Okay, what is the value of cos alpha minus beta? So cos alpha minus beta is equal to L1 V1 plus L2 V2 divided by under root L1 square plus L2 square into under root V1 square plus V2 square. So I got both the value cos alpha minus beta and sin alpha minus beta. What is the minimum distance? So minimum distance is this length. This is the minimum distance. So S, what is the value of S? This is S under root L1 square plus L1 square plus L2 square root. So if we multiply sin alpha minus beta into this number will be cancelled out. So minimum distance is L1 V2 minus L2 V1 divided by under root V1 square plus V2 square. So this is my first answer. Second answer is how much time it will take to reach from this point to this point. So for time we can use the formula S equal to UT. So time T equal to S divided by U. This is the total displacement S and this is the velocity V. So minimum time, so time required should be equal to S cos alpha minus beta divided by V. Okay, S cos alpha, this is S and cos alpha minus beta. So when I multiply with S, this number will be cancelled out. So it will come out L1 V1 plus L2 V2 divided by under root V1 square plus V2 square. Now this is V. So 1 divided by, what is the value of V? This is under root V1 square plus V2 square. So this root will be gone. So answer is L1 V1 plus L2 V2 divided by V1 square plus V2 square. So the question asked two parts. What is the minimum distance? This is the minimum distance, and at what time this minimum distance will occur? The time is this. So this is the answer.